All right, let's look at this next review exercise 6. We're going to round our answers to 4 decimal places. Here's the formula for a probability density function, PDF, for continuous distribution. The PDF of x is 3 times parentheses x minus 65 squared over 6,750 from x going from 50 to 80 and 0 otherwise. Here are the things that I want you to do. Verify that this is a legitimate PDF. Find some probabilities, probability that x is greater than 59, probability that x is greater than 72, and the probability that x is between 60 and 64, as well as the probability that x equals 4. And then use the formula of the PDF to find the mean and standard deviation of this distribution. I'm assuming that you're going to be using some graphing calculator technology. Now, the next slide I'm going to show you is going to have all the answers here. So I'd like you to stop and work this yourself without looking at this slide and without listening to my solutions. And then when you're satisfied you have your answer, then come back and check your work. Press pause now. Okay, so let me work this out on a TI-84. You could use another calculator to do this as well, but I'm going to use this one. Anytime I give you a formula, you're going to put it in. 3 parentheses x minus 65 parentheses square divided by 6,750. All right, so let's see if this works. To get this to graph, we need a window that's going to work. This formula might go other places beyond this interval, but the only interval that it means anything for us is from 50 to 80. We don't need to graph it outside of that. If I'm going to go that far out, I'm going to mark off the x's and 5s, and we could we could see, well, we could just start with the interval that we use for CDS. We may want to change that, but okay, there it is. And really, we didn't need to go nearly that far down. Looks like it's only going up by about 0.1 here, so we could maybe even change our window on y, say going from, say, negative 0.1 to maybe 0.2. And there is the graph. So what does the graph have to have? It has to be above the x-axis or on the x-axis. It's on the x-axis to the left and right of this interval, this window, and then it's right in here. And the area underneath, which is all shown here on the thing here, has to be 1. We can shade it here, but we can also calculate it from the home screen. So we can do Math 9, and we want to integrate from 50 to 80. The y value with respect to x, and this better turn out to be 1. Yep, it does. That verifies it. If you have the older operating system, it looks like this. Okay? If we want to find probabilities, we're using this Math 9. So I'll show you this version, and here you're going to see the older operating system versions across these 3 screens right here. Okay, so it's Math 9. That's our area calculator. It's called a definite integral. And we want to go less than 59. Well, less than 59 really means 50 to 59. So that's what we put in. 50 for the bottom, 59 for the top. We put in our PDF formula right here, which we have stored as y1, and then dx. And that's our thing here. So the last one's always x. Now, if you got the older operating system, to get y1, it's variables, right arrow to y-vars, function, and y1 like that. To the newer operating system, you can just go alpha trace, and then there it is. Or you can do it the other way. Probability of x is greater than 72. Again, it's a Math 9 to sum up that probability density. We're going to sum it up from 72 up to, was it 80, I think, right? 80, yes, is the upper end. And again, we're going to give it y1 and always an x at the end, because that's just telling us that that's our variable. And there's our probability we're looking for there, which we can round off. Between 60 and 64, same thing. I'm just going to do second enter and bring it up again. So the only thing I have to do is change the limits. The top limit is 64. And the bottom limit is 60. All right, that's good. There it is. There's the probability. The probability that x equals a number is always 0 for any continuous distribution. If you think about it as an area under the PDF, that's a height with no width. If it has no width, it has no area. So that's a probability of 0. Now, the mean of the distribution we can always find is what's called the expected value of x, which is math 9. And then you do all the x's that matter. In this case, it's 50 to 80. Oops. And if we just put y1 right there and dx, of course, as we saw, we get 1. But if we put x times y1 and then put dx here at the end, this is going to be the mean, which is 65. So what I'm going to do is store that as alpha m. Now I'm going to go back and hit Control Enter a couple, second Enter a couple times to get that formula to come back up. And I'm going to replace this with parentheses. Now I'm going to insert x minus that mean, alpha m, close parentheses, square. And if I do this, this will be the variance. So the square root of that answer is the standard deviation. Okay? And so that's the basic way we can get a mean and standard deviation if we know the PDF formula, making use of our graphing calculator. Okay? So that's basically things you can do with a PDF. You can graph it. We can even do some shading under it if we needed to, just to see that this is a little extra. You don't have to do this. But if we've got it graphed and we want to say, like if we want to find the probability from 55 to 60, we could also shade that by going second calc and choosing number 7 and choose 55 here and what did I say, 60 there for upper, and it will shade that from 55 to 60 right there and give us the probability. When you're done, you can hit second draw, do number 1 to clear your drawing, and then you're ready to shade some more if you want to see the shading. So if you want to see the shading, you can do that, but you don't really have to even do that. You can do everything from the home screen. But it is useful to kind of put that formula in y1 first so I don't have to keep typing it over and over and over again. Okay, so there's the screen with the answers and the screenshots from the TI-84 calculator. TI Inspire works very similarly to this.